Hello viewers, welcome to the channel Amazing Civil Engineering Studies. In today's video we are going to discuss about building construction mortar. Mortar. Mortar is the material used in bedding, jointing and pointing bricks and block in masonry walling. Characteristics of materials. General-purpose mortar can consist of sand, ordinary Portland cement, water, plasticizer, retarder, accelerator, pigments or coloring agents. Requirements of a mortar mix. The main requirement of a good mortar mix is workability. Bricklayers require a mortar mix which is described as fatty. This means it hangs on the trowel without being sticky. It spreads easily and it does not stiffen too quickly or too slowly. The mortar should meet other requirements to ensure that it retains its strength and durability during the life of the brickwork or block work. These requirements include adequate compressive strength, adequate bond strength between mortar and bricks, durability resistance to frost and chemical attack, joints sealed against wind-driven rain, an attractive appearance. The ability of the mortar to meet these requirements will depend upon the materials specified for the mix, the workmanship of the bricklayer, the protection of the materials and brickwork against adverse weather. Sand. Use it to create the bulk for mortar. There are two main types of sand used for construction purposes. WASHEDBUILDING sand, for mortars. Pure, clean sand has had all impurities washed out, e.g. soils, silts, clays, etc. Grit sand, larger grain sand used in the production of concrete works. Sandgesed for mortars should pass through a 5 mm sieve. Poorly graded sands, with single-size aggregates, contain a greater volume of air, and will require a greater amount of binding agent to fill in the spaces between each grain and make the mortar workable. Mortar made from poorly graded sand will be weaker and is more likely to shrink, leaving cracks into a grain can penetrate. Always see good graded sand. The silt test for sand. To carry out the test, a 250 ml measuring cylinder should preferably be used. Fill the cylinder approximately up to the 50 ml mark with a salt water solution, 1 teaspoonful of salt to 750 ml of water. simentAvailable ice up TOTHE 100 ml mark. Add more salt solution until it reaches 150 ml level. Shake the mixture well. Stand the cylinder on a level surface and tape it until the top of the sandis level. Leave the cylinder to stand for 3 hours. Measure the volume of the silt layer and the volume of sand. Formula is used. Special cements. As previously discussed, cement is mostly made from limestone, shale, and gypsum. It is used as the binding agent in mortars and concrete. The most widely used cement was developed in 1824 by John Aspdin, using a limestone called Portland stone. This commonly used cement is known as ordinary Portland (OP) cement. OP cement is mainly used for concrete mixes but may be used for bricklaying. If used for bricklaying, to make the mortar more workable. Over the years, the development of cement has created different types, for different purposes. Types of cement available. Masonry cement OP. Masonry cement OP cement with a plasticizer or an air entraining agent included. Produces a fatty mortar with high workability suitable for brickwork, block work, stonework and rendering. Sulfates resistance cement. Sulfates are corrosive elements found naturally in the ground. Sulfate crystals can enter walls below ground or walls retain a ground and attack O.P. cement. This attack takes the form of causing the cement to expand, causing cracking and splitting of the masonry. Rapid hardening cement. Chemical additives make these type of cement set and harden in half the time of O.P. cement. Portland blast furnace cement. Finely ground O.P. cement and granulated blast furnace slag, waste. Slower rate of setting than O.P. cement, therefore not generating the same amount of heat. Useful for very thick concrete walls, slabs or mass-filled foundations. Greater resistance to heat, seawater and acids. High alumina cement made from chalk and bauxite black in color. Develops high strength in 24 hours. Great heat produced during hardening, which can seriously affect its strength. Must be sprayed with water for 24 hours. Ideal for emergency work. Colored cements. By mixing chemically inert pigments with whiter OP cement. Cement strength slightly reduced compensated by adding gain extra 10% to the mix. White cement. Special selection of ingredients used in the manufacture of precast concrete products, reconstructed stone, renderings, and for the production of cement paints. Mortar additives. As previously discussed, there are plasticizers and air entraining agents produced in either liquid or powder form. Lime can also used for this purpose, but as mentioned earlier, lime a savory hazardous material to work with. Bricklaying sand can be purchased with a desired amount of lime already added. It is crucial that this type of sand is kept covered from rain at all times. Accelerators added to a mortar mix to speed up the setting process. Ideal for work in cold climates. Retarders opposite to accelerators slow down the setting process. Used in pre-mixed mortars. Waterproofers chemical, liquid powder, added to mortar. Used in rendering or work below ground. Antifreezers supposedly allows mortars to be used when temperatures fall close to freezing. Coloring pigments agents to color mortar in powder form very expensive, tends to bleach over time, needs care when batching. Note: all additives can weaken mortars. Should not be used below ground level. Mix proportions. The crudest method is gauging the materials by the shovelful. The amount on the shovel can vary according to the material. E.g., shovels of sand are often greater than shovels of aggregate. A slightly more accurate method is to use a bucket to measure the materials. As each bucket full is the same size, it will have the same volume. Volume mixing by inducing gauge box. Dry silo mortar system. The modern equivalent of the traditional weight batching mixer is the dry silo mortar system that is becoming very popular. The system involves the delivery of a large stand-alone silo that is charged with the correctly constituted mix materials in a dry state. The correct amount of water for a mix is automatically measured and added each time by a trained operator. Machine mixing. In general terms, this should be between 2 and 3 minutes. On no account should the mix be allowed to stay in the machine longer, because the materials will start to segregate. Hand mixing. This should take as long as required to ensure that all the particles have been completely integrated together. A high degree of agitation is required when hand mixing to ensure that any added plasticizer etc. has the necessary effect. Mixed mortar should never be retempered or knocked up with added water, because this dilutes the cement lime element of the mortar, which will result in a typical mortar mixes. Mortar is a mixture of the following materials in different combinations: sand, cement, and water. Sand, lime and water. Sand, lime, cement and water. Sand, cement, plasticizer and water. In site practice terms, it is possibly the least understood and most abused material on the building site. The design strength of the mortar should be determined mainly by the strength of the brick or block to bedetonit. The mortar strength should roughly match that of the brick or block, and in no case should it bestrange the neat. Pre-mixed mortars. Advantages: no space required for the mixer and storage of materials. Less transportation plant and smaller labor force required. Quality control of the materials is the responsibility of the ready-mix supplier. Economic for medium volume requirements. Consistency of coloring is easier to achieve. Disadvantages: part loads are uneconomical, so the system may not be suitable for small works. Waiting time for delivery may cause delays. More expensive than site mixing, so it is important to order the correct amount to avoid wastage. If the mortar is supplied by site mixing methods, it can be delayed or halted to compensate for any delays due to inclement weather, whereas mortar supplied pre-mixed may not have this flexibility. Mixing mortar by hand on site. Using gauze shovel repeatedly turn the ingredients into a pile, making sure that all the materials are thoroughly mixed together. Form a hole or indentation in the middle of the pile of dry mix. Add water to the mix. The amount of water should be approximate 0.6 of to 8 of cement. See water-cement ratios. The materials are remixed with the water from the middle until all the water has been incorporated into the mix. The materials are then turned repeatedly until the mix is a fatty workable mass. The mix is now ready for use. Adding more water to the mix will make the mortar easier to lay, but it will reduce the strength by up to 30%. Mixing mortar using mechanical mixers on site. Mixers can be powered by petrol, diesel, electricity. Procedure for mixing using mechanical mixers. Set up the mixer according to the manufacturer's instructions, or those of the site supervisor. Ensure that the correct power supply is available. Ensure sufficient materials and equipment are available. Carry out all safety checks and start mixer. Add the required water. Add the pre-gauged materials, adding the sand content first. Add more water if required. Allow the materials to mix thoroughly for approximately 3 minutes. Never longer, as segregation may occur. Turn out the mixed materials into a container or wheelbarrow. When work is complete, clean out the mixer. Water-cement ratio. The strength of mortar can be fixed by the ratio of the weight of water in the mix to the weight of the cement. Water-cement ratio equals weight of water in the mix. Weight of cement in mix. If a mortar mix has 50 kilograms of cement, and the total water does not exceed 25 liters. 1 liter equals 1 kilogram, the ratio will be 25 kilograms divided by 50 kilograms equals 0.5. Thanks for watching. For now, please subscribe, like, share and do not forget to press bell icon.